Hello and welcome to Module 2 second tutorial, Weaving Pattern with Lists. In the last tutorial, we built a mountain, a road, and a car, and along the way you started working with curves, surfaces, and frames. In this tutorial, we're going to dig into something that is at the core of everything in Grasshopper, which is data structure. Now, I'm going to be honest with you, data structure is probably the most difficult concept in Grasshopper, but once you understand it, and we're going to use a lot of metaphors for that, it really changes everything. It is the thing that separates someone who can follow a tutorial from someone who can actually build their own definitions from scratch. And it is not just about Grasshopper. Whether you are working with 3D geometry, text, spreadsheets, data sets, anything computational in Rhino or in Revit or any other software, the way data is organized is always the foundation. So if you understand this here, you're learning something that transfers everywhere. Before we start building, let me walk you through a few slides. At the most foundational level, Grasshopper allows you to manipulate data with algorithms, and these are visual algorithms. So we said that an algorithm is just a set of actions. You have data coming in on the left, it passes through actions or functions in the middle, and then you set the results. And then that's coming out on the right side. And that's definitely the flow in Grasshopper, which is from left to right. And that's always the case. So you can see here that data starts as something simple like a list of points. It passes through an action and becomes a curve. Those curves pass through another action and become the surface. So every step transforms the data. That is what a definition is, basically a chain of transformation from left to right. One thing Grasshopper does that is really helpful is that it's giving you these visual hints, which we've been learning along the way. And that helps you to understand the data flow better. So a thin wire means a single value, so that is one number or it could be 1 point. A thick wire means a list that's multiple items. And a thick dashed wire is called a list of lists or a data tree, which we can call, in this case, the entire thing as a data structure. Just by glancing at your canvas, you can tell whether you're working with one thing or many things, and you can pay attention to your wires that way. So they're telling you basically anything you need to know about your data structure. So how is data organized? At the simplest level, you have a single object. In this case, it could be 1 point or one number. The next level up is a list. So a list is an organized collection. You have, for instance, here 5 points in a row. You can have 10 numbers. A list has an order, and it's always starting from item 0. So we start counting from 0. And that order really matters because Grasshopper processes lists in sequence. And this is what today's tutorial is all about. We're going to see what happens when you change that order. So components operate on each object in the input, and they operate repeatedly. So give a move component 1 point, it moves 1 point. Give it a list of 100 points, it moves all 100 of them. And that's the same logic for everything. Now, the next level up is a list of lists. Each row is its own list, and all the rows form a list of lists. The actual data at the end, we call those leaves. The lists that contain them are branches, and together that is a data tree. And we're, of course, going to talk about this more, especially in Module 3. So every branch in a data tree has an address, right? Think about this as your own student ID number or your home address. And in this case, we're starting to always use this structure of starting to count from 0. So the leaves are the data, branches are the containers, and the tree is the whole structure. The numbers in the address are called indices. They tell you how to navigate from the base of the tree to the branch you want. So for instance, 0 semicolon 1 means at the first level, take path 0, and at the second level, take path 1. Like giving direction to somebody, right? So we're not going to work deeply with data structure in the tutorial, and that comes in Module 3 as I mentioned, but I want you to have this picture in your head now, because when you see those curly brackets in your panels, you will know what they mean. One more thing, when a component takes multiple inputs, the Grasshopper tries to match them based on the structure of their trees. If input A has 4 branches and input B has 4 branches, it matches them 1 to 1. But when it cannot match them because the list is longer than the other, Grasshopper has ways of handling the mismatch. It might wrap back to the beginning of the shorter list. We will look at this more a little bit in this tutorial and more in module 3. So to recap data flows left to right, a single item is a single item. A list is a collection in order. A data tree is a list of lists, and Grasshopper matches inputs by their structure. You do not need to memorize all of this right now, but keep it in the back of your mind, because when something unexpected happens in your definition, 9 times out of 10, it is a data structure that has the issue. So today we're focusing on lists. We're going to create 2 circles, divide them into points, and then shift those point lists in opposite direction. The shifted points get connected with lines, and those crossing lines create a weaving pattern. The only thing creating the pattern is the shift. So one operation on the order of a list and the whole geometry transfers. Now let's open Rhino and start building. So let's open Rhino, and we're going to create a new object, and we're going to work with small objects feet. And let's go to our perspective tab, and let's go ahead and call Grasshopper by either using the command line to type Grasshopper and enter, or use the icon here, however you see fit. Great, I'm gonna close this help window, and I'm going to situate Grasshopper window to the side. All right, so the way that we will construct that, we will start off by creating 2 circles, and then we will connect the lines between them. So we're going to start off by creating the base circle first. Let's go to our curve tab, and we're going to go to our primitive. And you'll see that there's many different ways of constructing a circle. In this case, the first one, it says create a circle defined by a base plane and radius. So let's just drag and drop that on canvas. And just remember that in this case, I have my draw icons on, otherwise I wouldn't see the icon. And then I have draw full names, right? So we started to look at planes in the previous example, and the size of the plane is determined under display, under preview plane size, and this is set up to 4. If you don't change this number, it would look like that. I think for this example, let's leave it at 4 so you don't have to change it. And basically the plane is the starting point. So in this case, it starts at the origin and then it's in XY direction. And then there's a radius, which is set up to 1. So let's go ahead and make a radius that's slightly larger. So double click on canvas, make a radius that starts from 1 to less than 5, less than 10, and give it 1 point decimal. So we're working in feet, which means Grasshopper will inherit that. So connect that to radius, so you can see that as much larger. And then let's try to understand what a plane is. So previously, I mentioned that plane takes an origin and it has 2 vectors. All the plane information is under our vector tab. We have a plane subtab. And you'll see that there's a few different options here. We can construct our own or build with existing. Let's grab, for instance, a YZ plane. So similar to the vectors, YZ plane is a unitized, so it takes an origin, and then it takes a directionality. So the origin by default is 0, 0, 0. That's any default origin is set up. And then it has a directionality. Let's connect the plane output to plane input. You'll see that now your circle is rotating. Okay, so let's also work with the origin. Let's provide another origin here. So this is a default point. Let's grab our construct point components under vector point, construct point. So we've already been using construct point. So I'm going to move this over. We've used this from the very first tutorial. So connect construct point to the origin. So nothing changes here. However, I can actually control the variables from here. So let's create a slider that starts from 0 less than 5 with 1 point decimal, 0 less than 5 with 1 point decimal, connect 1 to x, again, connect 1 to y, and connect 1 to z. And as we start to move the point, you'll see that the plane is moving along, right? So we can go in x, y, or z direction. We're actually going to keep this at 0, 0, 0. Just know that this is something we could modify. Also, for the sake of building this, we are going to keep this as is. So by default, if you don't specify a plane, no, let's go and grab under vector plane, let's grab an XY plane. So the XY plane is the default plane. If you don't specify a plane, it will go with an XY plane. So let's connect the origin to XY, and then let's replace this. So you'll see that it is basically just redrawing the same thing. So pay attention. Whether I create a pay attention whether I create a plane or not, your circle would be constructed the same way. So I don't need to preview these. Let's turn these off. Select and let's do Control Q just to turn them off. So if you don't specify a plane, it will just assume you're on XY plane. However, you could replace this as we mentioned. So you can have the XY plane or YZ or even XZ, or you can construct your own. So it doesn't need to be kind of orthographic. All right, so for this tutorial, we're going to delete the YZ and we're going to keep this at XY. And then we will proceed. So we have everything we need for this base circle. So we're going to select this and we're going to group it together. And I will right click and we're going to call this base circle. Great. So the second circle, we're going to have it a little bit larger. So we're going to move it up and scale, but they will be parametrically linked. So let's grab a move component. So move is under transform Euclidean move, or you can double click on canvas and type move. So what is it that I want to move? I want to move the circle that we just created. So connect the circle as input, and you see that by default, it has this 10 unit vector. So it moves it up 10 unit. So we can definitely adjust this. So I still want to move it in Z direction. However, I want to have control over how much. So let's go to vector subtab, and grab a unit Z, or you can just double click and type Z. So connect that. Now this is a unitized vector, so value 1. But let's create a slider that goes from 0 less than 10 less than 40. And let's connect this. So we could adjust the height as we see fit. So let's keep it at 20 for now. Great. And then we are going to also scale this geometry. So we can either scale it, then move, or move and scale. The sequence is, in this case, it's up to us. So depending on what you want to do with your geometry, you can decide whether you're doing one or the other. So scale is a type of transform. So we would go to transform under affine. And there's two ways to scale, uniform and non-uniform. We're going to get the uniform scaling. And it is asking you three things. One is, what is the geometry that you want to scale? So if you just connect the geometry, you'll see that it actually will make another copy, but it is half of the side because by default it has a 0.5 factor. And then also the center by default is set out to be here. So if I grab a default slider under parameters, input number slider, and just play with this vector, you'll see that closer this is to 0, which our component turns to red because I'm scaling it by 0, so it doesn't, it gives you an error. But you see that it's basically moving away, right? Because it's scaling it based on an origin. So this doesn't work because I actually want to scale around itself. I also want so basically I want to scale around itself, meaning I need to scale around this point. So I'm going to do one more thing before we proceed. Let's right click on the factor. And I actually want to scale this up. So go to values and turn this up to 4. So you'll see that then as you increase, it scales up and it goes away. So scaling up works, but I don't want it to go away. So I need to then scale it around its own center, right? So to do that, I can do two things. I can either move the point up or I can extract the centroid like we did in the previous example. So let's do that. We're going to go to our surface tab, under analysis, grab an area component. And the area component, it also extracts the centroid, right? So we're going to feed the geometry. So you'll see that it also extracts the centroid. And that's what I'm going to provide for center of scaling. So now when I move the slider, it is scaling around itself. So because Grasshopper by default creates this duplicates, because it's basically creating the history, we just need to, along the way, turn this up. So here I have this. So right now, we're going to just group this to itself, this part. And we always need to just reconfigure. And let's do Control G. And we're going to call this our top circle. So that's the base circle. And this is one we're going to call it our top circle. Great, so we have 2 curves. So the next thing we're going to do is we're going to divide each one and we're going to draw lines between them. So in our first tutorial 1.1, we learned how to draw lines. So if you have a start point and an end point, we're going to draw a line. But what if I have multiple points? So first we're going to find a component that allows us to divide. So under curve, division. So earlier we got the dash pattern component. So it has some other components for dividing. So under divide curve, it says divide a curve into equal lengths. So you can either do based on equal lengths or based on equal length. In this case, I want to do I want to do equal segments. So scratch that. Let's divide it by equal segments because I want the top one and the bottom one have the same number of divisions. So let's grab a divide curve. So then let's provide the base circle to the curve input, and you'll see that it by default has 10. That's how many parts it's dividing this to, and it creates then these points. It creates these tangents, parameters. So we're going to spend some time just looking at this specific curve. And in order for us to see this a little bit better, I'm going to turn off the background and I'm going to use the shortcut F7. You might need to hold down function, so F7 to turn off the background. So then this way we could see what we're looking at a little bit better. Great. So this is where we're starting to get introduced to the idea of a list. So every geometry that we're creating, if you recall, Rhino creates a history. So if we type the command list, then that's where we're able to keep track of things. So it's the same logic that we're going to be using. So I'm going to do a few things to explain the logic. So first thing we'll do, we'll go back to our base circle. We're going to look at our point. And let's grab a panel, and we've used panels so far to look at values, read information. So you'll see that this is right now telling me that my base point. This is the specific information. So a panel has 3 different parts. It has the index, it has the content of the index, and it has this thing called the path, and then it has the name. So let's compare that to this component here. So this is a single point. And here we have multiple points that I can visualize that. So now again, let's grab a panel and I'm going to provide this output. So let's try to compare them. So I still see three different things. One is there's these indices. So we start counting from 0, as I mentioned. This is in computation, we start counting from 0. There's 0 through 9, so that gives me 10 points. Then the content is specific coordinates. And then there's this other thing called the path, where right now I see that there's two different values here, right? So think about this as you are building geometry, the complexity of your data, your information is changing. I'm also starting to see something else. So far, most of the wires that we've looked at, it's a single line, but then as I am looking at the output of the points, I'm seeing a double line. So if you do not see this double line, make sure that in display, you have this option that says draw fancy wires on. If you don't have that on, everything shows up with the single wire, and that's really not going to help us in learning this next part, which is about data. So make sure you have draw fancy wires. So these are called fancy wires. I'm not sure why, but I think it's that's where it is. So let's try to understand what we are looking at. So let me switch to a slide and explain a little bit how data is organized in Grasshopper. So in Grasshopper, every time that we start building things, we're starting to count the relationship. And based on that relationship, we're organizing information. So think about these. There's many different metaphors that we can use to talk about lists and panels. I think about these as levels of complexity. So for instance, first we are making our point. On the point, I'm making a circle. So let's look at the list structure. So if I look at the curve, so on that point, there's a circle, right? So you can see that with circle, it has the same content. It's index 0, so there's one item, and then the path is that. So imagine you buy a piece of property, you add a house to it, right? One level, and then inside that level, you create multiple rooms, right? So in this case, imagine every point could be a room. Then if you want to reference each room, put them in a bucket of a sort. So here I just need to show some kind of a diagram. Then each of them needs to get its own index, right? So then you're adding one to its level. So that's one way to describe this. Okay, so we are going to also use a number of different visualization methods in order for us to look at our information content a little bit better. So for instance, if we go to our display, under vector, there's a component called point list. And this is going to be one of our visualization tools. In addition to custom preview, we will use this. So let's connect the output of points here. And there's a little bit of visualization here, but the scale is too small. So let's grab a default slider from parameters input. And as we start to increase this, you'll see that there's these numbers that are appearing right next to each point. So if you see the numbers starting from 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are actually the coordinates of each of them. So point list allows us to visualize the order of the points. And this is going to be really critical for us to actually understand how data is structured. So I'm going to group these two together. And we're going to say that this one, it visualizes. We're going to say point order. So if I change the number of counts here, so let's try to add a slider to number of counts. And I'm going to put this up here and then make this a little bit lower here. So let's make a slider that goes from 1, because at least you need to have one part less than 20. So let's try to connect that to the counts. So as you increase this, and you're always starting from here. Why? Because this is where your curve starts and ends. Just like surfaces, curves have seam. We looked at the seams in tutorial 1.2 where the start and end of the seam was something that we're adjusting. So basically you're just taking that start point and you're starting to add. And as you add that, the order of these points are changing. So Grasshopper, because it's for visual scripting, anything that will help us in visualization, it's going to be really, really critical. Great. I am also going to show you something else, which is the tangent. So we worked with the tangent, with the idea of the tangent in the previous tutorial, but let me visualize that for you. So if we go to our display tab and under vector, this is where we can also visualize vectors. So grab a vector display component. And here I want to display the tangent vector. So along each point, so you can connect that to the anchor. So a vector has basically a direction and an amplitude. So in this case, connect the vector as the tangent. You'll see that now these are the tangent vectors that are going along. So in the previous tutorial, when we aligned the vector, this is what we were looking at, right? So again, these are a great way for us to visualize. So I'm going to group this to itself, and then we're going to say this is our tangent vector visualization tool. And I'm going to put this to this section. And then the parameters are, let's look at the parameters. So this is based on where in the, so this is similar to the parameters and the idea of parameterization or re-parameterization that we've tested. So 0 is the beginning. And then it is right now set up based on distance. So the distance between here and here is 2.8. So basically, if that's the entire length, right, length of the curve, then it's distributing these along here. Okay, so let's switch this back to the coordinates, and we are going to just group these together. So these are the points on curve. For now, I'm going to just move them here together because we need to actually repeat the same process for this top curve. So this is the base curve, this is the top curve. I see that the wires are getting a little bit awkward. So basically one of the things in Grasshopper is that we constantly need to go back and modify them. So this visualization is something that I want to show you here. We don't need to repeat it for, well, we do need to repeat it. So let's try it again. So I'm going to here look at the same thing. So let's grab everything except for number of number, Control C, Control V. Move this actually. So let's go ahead and group this together, everything except for the slider. And I'm going to start to change the color of the section to something slightly different. So then the next one follows the same color convention. And before I make a group, I'm going to just copy this whole thing down. So then now instead of this top, instead of this base circle, we just need to replace this with the top circle. So just make sure that you're getting the wires correct. So the first one, the base one is going from the circle, then this one is going from the scale because it's the same operation we're looking at. Now, if you zoom out, you'll see that, yes, the top one also has the same divisions. And if I change our number of divisions, you could see that the information is changing. So for instance, the coordinates are changing because coordinates of each points, of course, are different, but the idea is that I have basically points along the top and the bottom one that we are looking at. Right here, that's the top one, that's the bottom one, and there we have it. Okay, so we have these points, and to make this more visible, I'm gonna turn off these two vector displays. So select them and do Control Q or right click on each of them. And then we're going to continue. So what I want to do next, I want to draw a line between each of these points. corresponding points. So 0 to 0, 1 to 1, etc. So the component that we're going to use is going to be exactly what we used in the first tutorial. And that's going to be under curve, under primitive, line. So this is a line component that has start and end, right? So the same thing that we looked at. So before I do that, I'm going to move this up here. So then there's a little bit less distance, and I'm going to move this down here along with these. So I think these are great for you to keep, to visualize things, but then it makes your Grasshopper environment cluttered. So what I want to do is to continue from here, right? And then at any point, if you like, you could select the components, you can align it right to left as you wish. Or here, for instance, I can then move the sliders out together. So it's actually a good thinking time anytime that you pause to align things, because then you could kind of reflect on what you have. Great. So the next thing we're going to do is we're going to connect these together. And I can either connect it from point to point or from the panel. We will do it from the component. And if you recall in the first tutorial, we connected one start point and one end point. So in this case, Grasshopper could work with single and multiple. And as long as your data is matching, meaning I have equal number of components in both lists. So in this case, if you hover over it, you have 6 points and 6 points. So they have the same amount. Grasshopper will do an operation. So an operation will be drawing a line, which let's try to look at that. So reduce that to 1. So I have a single point and a single point. And if you connect your point to the start point and this other point to the end point, it will draw a line. So then grab a panel to look at the output. So I have points, and I'm drawing a line between them. And you could see that with the line, it actually gives you the length. And in Grasshopper, it could do an operation once or multiple times. So let me show you the slide that we can talk about how Grasshopper is looking at two lists, and it matches number of elements in a list. If your list has the same number of elements, it would repeat it as many times as a list or as many times as the longest list. So let's see what that looks like. If I start to increase this, you'll see that with the number, then my list is increasing. So now as many times as I have these points, it's referencing those and it's creating a line. So this isn't a case where I have the same number of elements in my list, but watch what happens if that changes. So here I'm going to make a copy and I'm going to switch this. So this one is going to remain 6, and this one, I'm going to just connect a different slider, and I'm going to reduce this. So you see that as I'm changing the number, these are starting to connect in a weird way. So let's try to understand what's happening. So I'm going to move this momentarily, and this is something I need to do often, which to explain what is happening. So Grasshopper is starting to match. I'm telling it to do something, which is draw a line, and I'm providing it a list. It takes a list of points, so it takes this one, a start and end, creates a line. Then takes this one, and that one, and that one, right? So it gives me a line. But as soon as I start to change the number in one of them, so let's say I have 4, 1, 2, 3. So it goes 0 to 0, 1 to 1, it goes 2 to 2, and then it connects 3 to 2 because it doesn't know what to do with this extra. So it matches the last item of the longest list to the last item of the shortest list. So it doesn't matter how much I increase this, it is going to do this thing, which is matching that to that. So And it doesn't matter which list. So if I increase this one, you'll see that now it will do the same, right? So it creates some interesting pattern, but it might not be intentional, right? So just remember that Grasshopper is checking the length of your list. If the length is not the same, it's going to match the last element until that action, which is drawing line, is met. So it is going to repeat the function or the action that you're asking as many times as your longest list. So if this is 15, it's going to repeat this 15 times, and it's going to do that by matching the list. So this is our lesson in the way that data structures are constructed, some assumptions the program makes. But for us to actually do this well, I'm not going to need two sliders because I want to keep this consistent. So let's just delete the second slider and connect the first slider to our count, and there it is. So as many times as we have this division, then we have this sliders. Great. So I'm going to drag this out, and this is, again, you're starting to see how our Grasshopper window is becoming a little bit messy. Now, eventually, you're not going to need to have panels and these things for everything, but in the beginning, when you're learning, it really helps you a lot to have these things. Okay, so next thing we'll do is we will look into some operations inside our that deal with lists. That deal with lists. And before we do that, let's go ahead and save our Grasshopper file. Go to File, Save, and we're going to save this as we're going to save this as the same convention that I have on Canvas for you. So first name, last name, underscore tutorial M2.2. And let's do the same for our Rhino file. And press save. Okay, so far we have this pattern, but if you recall, the way that this experience works is that we are starting to have the capability to connect to, maybe instead of 0 to 0, I connect to 0 to 13, or I connect to, let's say, from this 6 to this other number, right? So there has to be a way where I could recognize that there's other patterns that I want to connect with. So under sets in our Grasshopper tab, under list, we have series of components that allow us to manipulate and work with different components of lists. And here you'll see a distinction between what we're calling a list and something that then later on we're going to call a tree. So trees are lists within lists. So when our data becomes more complicated, we'll be working with trees. For now, we're working with lists. And when you think of a list, just think about anything that looks like this, which means it has indices, it has some kind of a content, and then it has this thing called a path, right? So these components are going to be very useful. And in the next tutorial, M2.3, we're going to look into a few different components here. But for now, what I want to focus on is creating a way that we can create this twisting variable option. So we're going to work with a component called shift list. It says offset all items in a list. So this shifting impact is going to allow us to, instead of, for instance, connecting 0 to 0, I can shift by 1 and connect item 0 to item 1 of the other list.
So let's take a look at this component. So this component and all the components here are asking for a list, and a list could be list of points, list of lines, or list of just text, string, list of color, whatever that might be. So a list is just anything that looks like this. Is telling me that here we're going to shift by an offset of 1, and there's an option to wrap the data. So we'll talk about what these mean. So here, I don't necessarily need to shift both lists. And when we get to this point, I'm actually going to start to connect my start point from the panel, and then also my endpoint from a panel. So then this way we could just directly look at this information. We're going to work with that. So I'm going to compare this second divide on the second on the top curve by running the list here through here. And let's just see what the output looks like. And I'm going to make the list a little bit shorter. So then this way it'll be a little bit easier to see that. And I apologize for having a lot of things here. I'm going to make my screen maximize so we can just pay attention to data. Then I'm going to go back here and I'm going to reduce the number to, let's say, 4. So it'll be a little bit easier for us to see this. So here's my list of points on the top curve. I'm dividing it by 4, and then these are the 4 points that we see. And quickly, these are the points 0, 1, 2, 3, right? And that's how it's connected. Now, concept of a shifting is, now if you look at this, and your numbers are going to be different, right? Because depending on your height, these coordinates will be different. But just look at my screen and pay attention to the order. So this one starts with 8.35. I'm shifting it by 1. So you'll see that I'm basically pushing it up, shifting by 1. And now that item becomes the last item. Think about this like a conveyor belt, right? So look at this item 1, 0, 8, 35, 20. Now it's pushing by 1, and now that becomes item 0. Same in this order, right? So they're all being pushed up, and they're not exiting the list. They're coming back. They're being wrapped back. So let's look at this. I'm going to create a slider, and this is offset by a number. So this needs to be an integer. So let's make 1. Actually, let's make from 0, just to show you what 0 offsetting is. 0 less than, let's pick a number that's large, 10. Although I don't have 10 items yet, but let's just take a look. And let's see if we could organize it this way. So if I'm shifting it by 0, it means that it's the same, right? Nothing is being shifted, but just pay attention to what happens by 1. So it's pushing it by 1, by 2. So as you can imagine, so then this becomes the first item. So really just think about this as they're just taking turn rotating and it's being wrapped. So of course, as I have more elements in the list, and if I change that to 5, it doesn't matter. It's about reordering your elements in the list, right? So let's look at the wrapping option. So by default, this is set to true. So let's go to our params. Let's go to our Boolean toggle, and I'm going to set this to false. So when you set this to false, it's not wrapping, so it's not returning, right? So then see, like if I'm pushing it up, then it just goes away, right? So then it just goes away. So after that, there is nothing in the list. And if I do wrapping, then they're not going away, right? So that's the logic that we're going to use. It's a little bit like rotating your elements, right? And rotation is also something we can do where we rotate the geometry and your point will move. But the point of this tutorial is to introduce you to how data is structured. So we're going to do it this way. Great. So what I need to do is I'm going to hold this panels, and as you get more advanced, you don't need to use panels, but I'll go ahead and use panels. And we're going to use the output of the shift to the input up there. And when we look at now our geometry, you'll see that, let me just show you when it's 0. Then as you start to twist, right? So now they're crossing, right? So basically 0 is connecting to 2, 1, 0 connecting to 1, and then 3. And if I run out of indices, right? So it just goes, when I'm wrapping it, basically, you can just do this forever. So this is a really interesting way for you to create this pattern, and you're just switching the logic, right? So let's increase these numbers. And this is where we can start to see interesting patterns like 20. So of course, if you have a larger number, you can take more advantage of this when we have this beautiful weaving pattern that you're constructing. And again, the logic is you're just moving, changing how they are structured or organized. Great. So let's do a little bit of cleanup here. So I'm going to and group this to itself. And we're going to say, so let's actually name these as well. So this is top circle. We're going to name this as base circle divide points. Then let's do this is our top circle points. Then this is our top circle shift list. Then here we say that we are draw lines. Okay, great. So this works right now. So this works, but what I want to do is I actually want to set up the pattern that not only rotating this way, but I'm also rotating the other way. So in this case, we could repeat the same step. However, we can also shift in negative direction because you're either pushing data up or you can push data down. So let's go ahead and select and move this down. And here, I'm going to just leave up my definition for a minute, just so you can catch up. So we have a point that's connecting, creating the base plane origin. We're drawing a circle. Then we are moving that circle up. So this is a variable here. We're getting the centroid, and then we're scaling it based on the centroid. Then we're taking both the top curve and the base curve, and we're dividing it. Here I'm showing you information about the order of the list and the tangent vector. Then we're taking the top points, and I can either go directly out of points or I'm going through the panel just to show you what shift list is. And then we're using the shortcut Control Alt left click. So we are using the shift list component under list, under sets list and shift list. And we are looking at how to basically change the order. So then our lines are connecting to other. So I'm going to repeat this one more time. And let's try to say, so in this case, for instance, they are shifting, if I look at this, they're shifting counterclockwise. So I'm going to say this is counterclockwise. And then the other one, we're going to shift it clockwise as a way of kind of distinguishing those. So here, the first thing I'm going to do is I'm going to actually use the same number so I can control them the same way. So I'm going to get rid of the slider and I'm going to look for a negative number. So under maths, under operators, not only we can do operations, but we can also get a component such a negative. So it's just taking this number. So in this case, if it's 6, this is going to be -6. So I'm going to, if I look at the list before and after, this is going to be a long list. You'll see that if I shift it the other way, basically it will go the other way. Instead of pushing up, it will go down. Okay, perfect. So I'm going to add this to the group. And we're going to go ahead and draw the same lines again. And I'm going to keep the start connected to the base. So I'm going to do Control-C, Control-V. And all I need to do is to just replace the endpoints. Now you see that now we are actually connecting to the other way as well. So you are once drawing these curves clockwise, and then, sorry, counterclockwise, and then next time you're connecting them clockwise. We did all of this by just changing this number, right? So if it goes to 0, right now there will be overlapping, right? Because we're drawing it twice. But then you can see that you have this beautiful pattern that you're creating. Okay, now if I, depending on the number, whatever the midway is, that number is going to have it crossed. But once you pass that number, so if I'll change the value to, let's say, let's move it up to 15. Once you cross that number, you're starting to open up the pattern again, right? Because you're going in the other direction. It's a very simple way for us to create these relationships. And then let's keep it a little bit more wide. And then we have so many other variables, such as this is the scale of the base. So it's basically makes everything parametric. Then you have the relationship to the top. So this is, if it's 1, it's the same, even if it goes slower. So you have one simple pattern, but see how many different variations you could construct. So if this is 1, it's going to be exactly the same size, which is 100%. But then again, you can go in the other direction. Okay, so for now, I'm going to keep this 1.5, so 150. Okay, so what we're going to do next, we're going to do a little bit of visualization to make your geometry come across better. So I'm going to also use the same name that I use here. So I'm going to copy that and Control-G. So let's also label that. And instead of top, we're going to see this is, yeah, the same description applies. Okay, so next thing we're going to do, we're going to pipe. Now, this is one of those cases when, as soon as you introduce surfaces and piping, your geometry could become larger. So let's go ahead and save. So piping is, we used it yesterday, so under surface, freeform, and pipe. So we're going to pipe these curves first, and you can see that now this is quite thick compared to that because it's a radius. So let's grab a radius. Let's double click and create a radius that's 0.1 less than 0.8. And that. So that's a way to pipe that. And I want to keep these colors different. So therefore, I'm going to keep the geometry different. So we're just going to copy it and then connect these other lines. So I'm going to keep the radii the same. But we're going to delete this. We're going to do 2 different custom preview. So let's grab that under, again, display, preview, custom preview. And let's grab a color swatch. Give it a number you like. Then I'm going to group this again. And let's select a slightly different color for this one so then it looks slightly different. Okay, so I want you to pay attention to the wires that are coming out of our pipe component. So if we look at our definition so far, we started with wires that are single line. So we said single line, these are lists that only have one element. As soon as we migrated to creating multiple points on the curve, this is where we have the double line. So it means that there's more than one element in the list. However, as soon as we started to create these pipes, are the look of the wire changed. So right now these are dashed lines. And again, all of this you need to have the fancy wire on, otherwise they look the same, right? So what this means is that your geometry right now is starting to actually break down further. So if I look at the output here, you'll see that now our data, it's starting to look slightly different. So up to this point, we have these curves, right? These are the lines that we're lofting. So it's one list with this many elements. But then after I lofted them, the geometry looks more complicated. So each of them, it looks like it took these numbers 0, 0, 0, which is the path or the address, and it actually added that to the end, became 0, 0, 0, 0. Then became 0, 0, 0, 1. So this is the path or the address of the geometry. Certain operations, it allows you to actually make the geometry more complex. There's a number of different operations that we can do with this. All of these operations with data, you will find it here. And we're going to look into this more in the next tutorial. But for now, just understand that understand that this is where our geometry is becoming more complex. Okay, so we have the same setup here. And the next thing I want to do is I want to create these nodes or connections anywhere that your curve is intersecting. So for a moment, let's select your custom preview and turn it off. So select and Control Q. Let's also turn the pipes off. And let's just look at this in terms of the curves. So I'm going to group the pipes and the custom preview together, and same with the top one. And then we're going to actually add this group inside here. So you can actually add groups within groups. Select the pipe and the custom preview, then right click on the color box of draw line between base and top circles, tell it to add to group. So now we can have basically geometry within geometry. Same thing with the select what you want to add, right click and tell it to add to group. So it just becomes easier for you to work with. Okay, so next thing we're going to do is we're going to find a way to draw some kind of a connection, in this case sphere, where you have these intersections. So for us to do that, first we need to be able to basically extract these intersections. And I'm going to actually go ahead at this point and turn off the points that I don't need to see. Let's go to the very beginning. And for instance, the circle and the base point, let's the base circle point and these two go ahead and turn off. We're going to keep top and bottom circle for now, but let's also turn off everything here that are basically for order of the points, so it looks quite clean. Here, it's just dealing with data. We're going to keep the lines. Great. So earlier when we were looking at Grasshopper, I introduced you to a tab called Intersect. And Intersect is where you're able to basically find ways that you can extract information. So we're going to go to Intersect Physical, and we're going to look for a component called Multiple Curves. And you can see from the icon, it says Solve Intersection Events for Multiple Curves. So grab that here. And I'm going to place that right in between here. And the curves that I want to connect with or find the intersection are these lines. So connect that as curve input. Then I also need to add these. So make sure you hold shift, and connect these together. So now you'll get all of these intersecting points, right? So just make sure that you hold shift, otherwise you cannot connect more than one wire. I'm going to try this again, right click, go to disconnect. You see that here I can disconnect one or the other or disconnect all. And again, select one, and if you don't hold shift, it's only going to take the latest. So just hold shift, connect these, and there you go. So now these are points that we can use to do something, such as maybe let's draw like spheres. So spheres are type of surface. So under primitive, we can use a sphere component. And let's go ahead and drag a sphere component here, and I'm going to connect the point input. So it's asking for a base. That's very similar to what we saw earlier with the circle, right? So a plane, a frame, or a base, it's the same logic. So by default, the base is set up to 0, 0, 0. That's why we're seeing that placeholder there. So a base is a base plane or a plane or a frame. All of that means the same thing, which means it could take a point as an input. In that case, it's going to assume the default plane is XY. Otherwise, you can provide custom frames. Just go ahead and connect the points. It might take you a few seconds for these to draw. So it is doing the work, but it's quite maybe a little bit heavy because it's drawing these large elements. So if you feel that your Grasshopper is lagging a little bit, maybe let's go to the preview option here and go to wireframe, or I want to introduce you to also this this component on the right, where here, make sure that your simulation, your rendering is set up to low quality. If you go higher, it's gonna even lag mode. So if I do disable, it's same as in a sense the wireframe, right? So just go to low quality. And then let's reduce the radius. So make a slider that goes from 0.1 less than 0.5. And when you're connecting a slider for something that's starting to lag a little bit, you don't want to drag it. You just wanted to maybe double click and change this to maybe 0.3. There we go. So I think this would work as something that's representing connections. So let's go ahead and turn on the preview of these pipes. Control Q. And there it is. So it's kind of acting as these connectors details, although we're not bleeding or anything, but I think it's an interesting pattern. So let's group this to itself and say these are action. Okay, so let's also grab another custom preview. I can just copy from here. Then just add these. And then decide what color you want to use. I'm going to go a little bit darker here. Something like that, maybe, or lighter. Change my mind. Maybe I want to do a gray tone. So over here you can do either RGBA. So that's alpha channel, or you can do hue, saturation, value, and alpha channel. So let's just do something like that. And there it is. I'm going to just add this to the group. And here we have it. So play with the values a little bit. You don't need to make them a specific value, just change this how you see fit. Spend some time. As I said, don't drag this because it will maybe take a while for it to calculate. You can just easily, with these things, you could make them basically make it and then double click. So same thing here. If you want to change the shift list, don't drag it, make this double click and then change the value. So it will perform better if we are maybe maybe when we are making the changes. So right now it's not let's go to a number like 11. Yeah, so you just want to avoid that half number. I'm gonna go to a number like 8. There it is, right? Okay, so spend some time just fine-tuning this. As I said, if you feel like it's heavy, you can do no preview at all or a wireframe preview, and then that's how you could adjust it a little bit better. Like right now, it's more like I can easily do that. You could also, if you want to go the negative direction, you can do that. And then these are also parametric and you can work together. So spend some time like finding what you think is an interesting variable. And then let's do some cleanup. I'm going to go here. And last thing we need to do is we need to also pipe this top and bottom ones. And let's also turn off these. It's just good practice to turn off things that you don't need to see. So that's going to be a piping operation, and what I want to pipe is basically this top and bottom one. So this would be one of those cases that I know, for instance, the operation is piping, so under surface freeform pipe. And because we're building this logic left to right, you can, if you decide to have your lofting down here, you can certainly do that. But I want to show you a practice. We talked about parameters, geometry containers earlier, and we worked with a point container before. Let's look at a curve container. So curve containers, they can take any types of curves. And this is one of those cases to make your definition a little bit more clear. You can actually pass curve geometry and then connect it from a container. So imagine it's an empty box. You're just trying to organize things. So then hold down also your scale geometry. So hold down Shift and connect this to this curve container. And then connect the curve container to curve input. Do you need to do that? Absolutely not. You can go directly from here, but I want to show you one benefit of using a curve container. If I want to then move this over here, I can, then I could use that. Then what you're going to notice is that sometimes these wires could be quite messy. So one thing you could do, you could right click and you can change your wire display. So by default, this is fully drawn. You can go to faint. So when you do faint, it becomes a much lighter line. Or you can right click and go to wire display and make it hidden. So it's completely not there. You can see it kind of having a receiver. So this is your preference. Just sometimes when you don't have that, maybe you're gonna think this is just sitting there. So if you like, my preference is to work with faint, so you're still aware that these connections exist. But if you think it becomes distracting, that's one way to manage that. Okay, so next thing, we're just going to make another slider. So go from 0.1 less than 0.6 less than 0.9. Then connect that to your radius so it's a little bit thinner. And you can adjust this. Something like that looks good. And then let's also Control J, Control V, and give it a specific color. And you can decide based on your design what this top and bottom rings might be. I'm going to keep them gray, the same color as these connections, so there's kind of more continuity, right? And the very last thing, we're going to group this together. Say these are our base and top circles. Okay, so feel free to spend some time coloring things. So you can certainly regroup, rename. The coloring is for your own preference. So if you like to keep everything the same color, you can certainly do that. If you like to adjust the colors for the grouping, you can certainly do that. It is all set up for this visual basically scripting environment to make sense to you. So please use it as you see fit. For me, what's really critical is to see you follow along the logic, organize your panels as you like, change the preview of the panels as you like, also adjust the numbers as you like. So each of you should have your own custom combinations that I'm going to look at. So I hope you enjoyed this tutorial, and in the next one, we're going to spend more time learning about lists, and we're going to start to look into data trees, and we're going to learn about the logic of attractors. Thank you very much.